Okay. So we are in paper number 2, Edexcel's May 2024 paper. Um, right, the enthalpy level diagram. These are very easy questions. The rate of the reaction rate, reaction kinetics. Right, these are discussed under reaction kinetics. Which arrow shows the enthalpy change for this reaction? Um, Right. So always the enthalpy change is between reactants and products, and it is an endothermic reaction. So it is A, right? It is always between the reactants and products. Here it is activation energy. B is for activation energy for the reaction one, and for the reaction two, activation energy is B minus C, right? The difference between these for the backward reaction. Yeah, for the back for this reaction, there's no way to derive the activation energy with these symbols. So anyway, they are asking about the enthalpy change for this reaction. It is reactant minus products arrow A. Sodium chloride dissolves in water to form. Uh, this first easier. Right, sodium chloride dissolves in water to form solution because of the interaction between sodium chloride and water. What are these interactions? So sodium chloride means it is what? It is an ionic lattice. So when it is getting dissolved, you have ions. So when the in water you have the strongest interaction is hydrogen bond. Um Sodium chloride and water. So hydrogen bonds are between uh, water molecules, right? But between ions and water molecules, it's ion dipoles, right? Ion dipoles means water molecules have permanent dipoles. These dipoles are very stronger, so therefore we are calling them as hydrogen bonds. So it is ion dipole interactions, right? So answer is C. Okay. Next one. Which equation represents the reaction for which the enthalpy change delta HR is the main bond enthalpy of the carbon chlorine bond in CCl4, right? Mm, mean enthalpy, right? Right. Right. So the here it means bond enthalpy of carbon chlorine means um, right. So it means there's only uh, one bond means broken. So therefore, um, yes. So we are looking at only one bond. There should be only one bond, right? So therefore, it is 1/4 of CCl4 because CCl4 containing four carbon chlorine bonds. See, so here we are talking about only one bond, right? So the enthalpy is for what? We are talking about of uh, mean bond enthalpy for breaking of one carbon chlorine bond. So we are talking about one carbon chlorine bond. So therefore, 1/4 of this is being broken. So therefore, we are getting the breaking of carbon chlorine, right? So therefore, 1/4 of carbon is made and one CO, right? So answer is B here. Okay. This question is about boiling temperatures. Which isomer has the highest boiling temperature? Uh, Highest boiling temperature means stronger intermolecular interactions. So stronger intermolecular interactions means all these are hydrocarbons. So in hydrocarbons, the only intermolecular interaction force IDID, right? Or induced dipole and instantaneous dipole. IDID forces are strongest when it is branched more. So as you can see here, uh, where molar mass, right? When the molar mass is getting larger, number of electron cloud is number of electrons in the molecule is getting more and more. When there are more electrons, the electron cloud is also getting stronger and stronger. That is also one factor. But here in this case, it looks, by looking at the surface level, it looks all these molecules are the same. The only difference is branching. Highest boiling point means most IDI, strongest IDID forces, strong IDID forces are there when it is least branch. When it is least branch, more area is exposed, more point of contact is there. More point of contact is there because of better packing. Since it is not branch, they can pack well. So therefore, stronger intermolecular interactions are there. So the answer is A. Easy ones, right? Which compound has the highest boiling temperature? So out of these, again same factors come into play. Intermolecular interactions. Out of intermolecular interactions, uh, uh, hydrogen bondings are the greatest. Hydrogen bondings are there between oxygen and hydrogen, nitrogen and hydrogen, fluorine and hydrogen. Because oxygen, nitrogen, and hydrogen, they contains lone pair electrons, right? So as you can see here, uh, OH bond is there in alcohol, and here two OH bonds are there, diol, right? So highest boiling point is there when the intermolecular interactions are strongest. Strongest intermolecular interactions are there between alcohols. So diol means it contains two OH groups, right? So two OH groups are there in butane 1,4-diol because they have, uh, for each molecule it contains on average, um, one, two, right? So it means since there are two OH, right? It contains on average four hydrogen bonds. Right? Okay, let us move on to the next one. Steam passed over heated magnesium. Which reaction occurs most readily? Right? Uh, Readily means uh, fastest reaction, right? So readily, right? So the hydrogen is released. Steam is passed or occurs most readily. So sorry, when magnesium is reacted with H2O. So for example, with water it is not reacting, right? But if with steam, it is forming oxides. So between this and this, it should be MgO because this is O levels, right? Uh, uh, Valency of magnesium is 2, oxygen valence is 2, so therefore 2 to 2 cancelled off, MgO. This one formula is wrong, right? So this thing you should know. Overheated steam with magnesium, what is the product? Okay, because it is rapidly reacting, so they have mentioned it, right? uh, most readily means reaction is happening fast. So therefore happening fast means it cannot be magnesium hydroxide. If magnesium hydroxide is formed, this reaction is a slow reaction. But they mention it's most readily, right? Reaction is happening superbly. So therefore, it won't stop at magnesium hydroxide. It goes up to magnesium oxide. Since this is the best product, most complete product you can have, right? Magnesium hydroxide is something like, incomplete combustion, carbon monoxide is there, but complete combustion, carbon dioxide is formed. But here also, this is readily being reacted, completely being reacted, a better reaction. So therefore, it won't stop at magnesium hydroxide, right? That is why you don't expect to get magnesium hydroxide there. What are the products formed when lithium nitrate and calcium nitrate are heated separately? Uh, uh, right. Lithium nitrate and calcium nitrate. Um, Lithium is in group number one, calcium is in group number two, right? Uh, but we know usually, right? Even though lithium is in group number one, usually group uh, sodium, potassium. After lithium, you have uh, sodium, potassium, rubidium, cesium, francium. So when they are reacted with, when their nitrates are reacted, right? You get what? You get the product as what? Uh, Nitrites, right? Group 1, you are getting nitrites. But in group 2, you are getting what? Oxide, right? Group 2, metals are giving oxides, right? So therefore, A is wrong, calcium oxide is the answer, and nitrogen dioxide and oxygen. Lithium, even though lithium is found in group number 1, it is behaving in the thermal decomposition reaction of carbonates and nitrates, just like group 2 elements, right? Group 2 is beryllium, magnesium, calcium, strontium, barium, radium. So they are giving oxide and releasing nitrogen dioxide. So it cannot be calcium nitrite. It must be calcium oxide, nitrogen dioxide, and oxygen. And also for lithium, it mentioned as lithium nitrite. It cannot be lithium nitrite, right? Why? Lithium is also giving oxide, so therefore it cannot be B, right? My bad. So I saw it as lithium oxide. Lithium oxide is there. Both are giving oxides. Here, lithium is the only element in group number one, only metal in group number one that is giving oxide when the nitrate is heated. So you are getting lithium oxide and calcium oxide, right? And nitrogen dioxide and oxygen is released. So the answer is D, right? So these things you must remember. You may think since lithium is in group number one, it may not get decomposed. No, lithium, even though it is in group number one, since it is found in the top of the group, it is giving some properties of group number two, right? Um, in our syllabuses, we don't discuss about those properties. Sometimes, even though these elements are sometimes giving uh, not not those group wise and period wise qualities, sometimes they give uh, longitudinal relationships, right? So we don't discuss those things in the syllabus, right? Okay. So the answer is D. Uh, right. Okay. Group number two compounds give different colors in the flame test. The best explanation is that the cations have different, mm, right. So when the electrons in the outer shells are getting excited, then again they are getting de-excited. When they are falling back, if some of these metals emit these energies as radiation, these radiation energies are sometimes in the frequency of visible range. So if these radiation energies are in the visible range spectrum, so we are starting to see colors, right? So it doesn't mean other elements are not uh, getting de-excited after being excited and not releasing radiation. No, they are also releasing energies as radiation, but those radiation frequencies are not within the visible range or the visible spectrum. Best explanation. Uh, Gaps between electronic energy levels, number of electrons, ionization energies. Gaps, right? Different cations have different energy gaps, right? So when they are getting de-excited, right, they are releasing energy respect to the uh, energy gaps, right? Since these ions have different energy gaps, the amount of radiation energy they are releasing are different from each other. So therefore, different energies means different frequencies and wavelengths. Different frequencies and wavelength means different colors. So difference in the gap between the energy levels, it is what gives different colors, right? So understand the question. Gaps between electronic energy levels, right, have different, right, cations have different gaps between the electronic energy levels. Because of that difference only they are giving different colors. Okay, all those things are not wrong, right. uh, different ionic radius ionic radii is also right, but it doesn't mean why there's a difference in radiation energy. Difference in radiation energy is always due to different gaps, right? So it explains much better, right? Because radiating energy is respect to the gap between these energy levels, right? Ionization energy does not tell you ionization energy is not the ionization energies, it's the de-excitation energies, right? Ionization energies means completely electrons are being removed, right? But here it is about de-excitation energies, excited and de-excited. So in that case, electrons are not completely being removed. In ionization energies, electrons are completely being removed. So that is not the reason you are start to seeing different colors in the flame test. Different colors are given due to the de-excitations of the electrons. Right. Two tests were performed on an unknown ionic compound. Right. Right. Silver nitrate solutions were added to a aqueous solution of the compound, forming a white color precipitate. So it could be chloride ions. Flame test carried out on the ionic compound to give red color flame. Flame test is used to identify the cation. So red color is given for which one? Uh, Red color, strontium, right? Strontium is the cation, right? So in that case, strontium, the only answer is yes, strontium and chloride. So chloride is anyways, it's easy detectable because silver chloride is white color. Strontium is the color that is giving red color, right? Okay. Which compound is exactly 9 moles of oxygen for complete combustion of 1 mole of compound? Uh, So you have to write the balanced equations, right? 9 moles of oxygen. Right. So without that dose, you can do it. Right? There's an easier way of doing it. You don't need to balance it actually. Now, if you need 9 molecules of oxygen means, right? Uh, so in the complete combustion, you must have what? Carbon dioxide is released. So it means this oxygen is in there, uh, also in water, right? So in that case, you will have to balance it and see, because this oxygen is carried by water molecules also, right? So therefore, we'll have to write the balanced equation and see, right? So right. So when after you balance it, the stoichiometric ratio should be 1 to 9, right, between the uh, organic compound or hydrocarbons, right? So we'll see whether it says 9 oxygens, 6 carbons. So if you have 6 carbons here, then you have 12, then you have 6 oxygens, right? So therefore, number of hydrogens must be 12, right? So in answer 9 cannot be this answer number 9. And if you look at 5 carbons, if you have 5 carbons, 5 times 10, 5 times 2, 10. So you need another 8 water molecules. So 8 water molecules means you have you should have 16 hydrogens, but here you have 12 hydrogens. That is also wrong. If you look at here, it says 6 carbons. So if you have 6 carbons here, right, then 6 times 2, 12. So remaining you have 6 oxygens. So 6 oxygens here, right? So 6 times 2, 12, and yeah, 6 carbons and six carbons and 12 hydrogens are okay, but there's another extra oxygen, right? So it cannot be. So only remaining answer is this. So if you have 6 oxygens, 6 carbons, and 12 oxygens are there. 12 oxygens there means another 6 oxygens are there. Uh, 6 oxygens are there, right? So it says 14 hydrogens, 7 times to 14. Okay. Then altogether you have 12 oxygens and 7 oxygens. So altogether 19, right? And therefore you need to have one more extra oxygen there. So 9 times 2 is 12. With this oxygen it is 19. And your hydrogens are also balanced. So only thing is you need to have a extra oxygen here. If you have extra oxygen here, then okay, 9 times 2 is 18 plus 19. 6 times 2 is 12 plus 7, 19. Number of hydrogens all are released from this one. 7 times 2, 14. And number of carbons are all released from here. It is also okay. So it is the, yes, D must be the answer. I use a different method, but it may not be easy for you to find the answer that way. Sometimes you may get an idea about how to do it, But the thing is, you will have to then write the balanced equation and for each one of these and find. Right? But I haven't done that. I just with my knowledge, I have just count the number of carbons and oxygens and check whether the each answer is correct. So yeah, it looks this is the answer. Otherwise, my advice is in exam situation, tense situation, you don't have time to play around like that. But you can try out this method before your exams. But at the exam, don't do these things. So just you will have write the so leave it for later. This one is an easy one, but it takes a bit of time because you will have to write the balanced equation and check whether the ratio is 1 to 9. Right? Okay. Is it okay to? What did you do? Did you balance it from scratch? It takes bit of time, right? Otherwise, like just like I did, you can cheat a bit there, but I don't recommend it because it may sometimes confuse you. Which solution remains clear on addition to barium chloride solution? Dilute sulfuric acid, barium sulfate is there? No. Silver nitrate. So when you have the culprit as sulfate, every time in any syllabus, Cambridge and Edexcel, barium sulfate, white color is there just like bread and butter. So without, so you should know it. Silver chloride, silver bromide, silver iodide, barium sulfate, bread and butter questions. In each and every syllabus, IB, AQA, OCR, Cambridge, even in nationals, these are being tested just like bread and butter, right? These are very prehistoric questions, right? Yeah, sulfuric acid means sulfate ions are there. You are getting a white color precipitate, not clear solution. Silver nitrate, silver chloride is there. Silver and chloride. Sodium nitrate solution. Sodium nitrate solution, barium chloride. It looks like the answer. Sodium sulfate, no sulfate. So it is C. Answer is C, right? We have 20 MCQs, right? In a titration, a conical flask containing 10 cubic centimeters of 1 mole per decimeter cube sulfuric acid is fully neutralized by 25 cubic centimeters of potassium hydroxide. Titration is carried out using methyl orange as an indicator. What would be the color chain at the end point of a titration? Right. Methyl orange is used. Titration is carried out between sulfuric acid, potassium hydroxide. So you must know if the indicator is methyl orange, it is happening in what? 2 to 1 ratio, right? So it means, uh, right. So values are also given. Uh, Titration is carried out with methyl indicator. What could be the color chain at the end point of the titration? My vote. Red color is it's like uh, in the conical flask, you have sulfuric acid. In the burette, we have the hydroxide. It could be the other way around, but they say in the conical flask, you have the sulfuric acid. So therefore, the conical acid is moving from acid to alkali. In the acid color, it is red to B color. It is red to orange color. So even with these kind of experience, even sometimes even I forget the color. So what I always think is, uh, what do you say? More intense color is in the acidic medium. Acid is intense. So red color is in the acidic medium. Intense color. Orange color is alkaline. Alkaline is less intense. Right? So my logic is wrong. That's the only way to memorize because otherwise things like this always sometimes even I forget. Right? With the color change. In phenolphthalein in the acidic medium, colorless. Right? In the basic medium, light pink color. So those things you must remember. Right? There's no other way. So red to orange color. It is moving from acid to alkaline. What is the concentration in most solution of potassium sulfate solution produced by this reaction at the end point of two significant figures? Potassium sulfate, right? They are asking about potassium sulfate. You have the so best thing is to write the balanced equation potassium hydroxide and sulfuric acid. So you are getting K2SO4 and water. Uh, yeah, yeah, red to orange. Did I say orange red? Red to orange. I said other way around. Right? Red to orange, yeah. Okay. Right? It should be red to orange, right? So potassium sulfate, so, 2 to 1 is the ratio. So, so they have given me even the values, right? So they are asking about amount of potassium sulfate. Sulfuric acid is fully neutralized by potassium hydroxide. So the calcium sulfuric acid is fully neutralized. No? So therefore, amount of sulfate ions is equal to the number of moles of sulfuric acid used. So in thousand you have one. This is the amount of sulfate ions they have poured in. Right, so it is completely being neutralized means all the sulfates have been converted into K2SO4. And the other thing is there's a dilution. So they have added 25 here and 10 here, it is 35 altogether. This amount of moles of sulfates are now in 35 cubic centimeters. Then concentration means in 35 you have this amount, then in 1000. 1000 to 1000 cancelled off. Uh, 10 over 35. Let's see. 10 over 35 means 0.33 something, less than zero point 0.3, no? 10 over 3 means 0.33. So 10 over 35 means the ratio must go down, right? So it must be 0.29, right? Did you understand my logic, right? I don't know whether I am being too mathematical for you guys, right? So, so without simplifying, I just assume the answer should be 0.29. Why? The ratio I got is 10 over 35, right? If the ratio is 10 over 30, the value was 0.33, right? 1 over 3 means 0.33, no? But it's 10 over 35. 35 means the denominator is much greater. Denominator is much greater means this value should go a little bit down. Because here for 30 denominator, here for 35 denominator. So we can assume it is 0.39. Is it understood? So otherwise, you will with the calculator, you just plug and see because I am kind of lazy to use the calculator because I am used to do all these things manually, right? Without using calculators much because I have practiced since I was a student, just like you guys. I used my logbooks and I had to do all these things manually with my brain. So yeah, so I am kind of now used to it, right? So I am lazy to use the calculators. So I am doing these sums manually, right? So you don't need to be like that. Just plug in and get the answers. Okay. Information about the uncertainty of each reading. Oh my god. Oh my god. There are more, right? With that it's so. Oh, there's more. Interesting, huh? Right. Okay. Right. Information about the uncertainties of each reading used to measure the volumes of solutions of nitrogen are shown. Sulfuric acid, pipette, potassium hydroxide, burette. So it means potassium hydroxide is in the burette and the sulfuric acid is used in the pipette means it is in a titration flask. So uncertainties are definitely much greater for pipette. Oh my god, sulfuric acid. Pipette. It is like kind of like a more accurate pipette, right? 0.04. Burette is okay. Pipette, I haven't seen a pipette unless a micro pipette, right? Anyways, very good pipette, right? 0.04. Much accurate than a burette. Which statement is true? Percentage uncertainty of the volumes of sulfuric acid is more than the percentage uncertainty of volume of potassium hydroxide. So when you take the percentage uncertainty, it is always about the uh, uncertainty over volume transferred, right? So if we assume burette volumes are greater, if the burette volumes are greater than the sulfuric acid volumes, right? Now if they are measuring the same volumes, percentage uncertainty of the pipette is less, burette is more. If we assume they are measuring the same volumes, let's keep it like this. Percentage uncertainty of volume of sulfuric acid is 0.025. Are they talking about the same? They are talking about this, right? Oh my god. So in that case, sulfuric acid 10 cubic centimeters using a pipette and 25 potassium hydroxide 25. They are in that case percentage uncertainty in the burette is much less since the volumes are different. So therefore, yes. So right. So we have to calculate and see. 10 and 25. So by when looking at it, feels like potassium hydroxide is having a low percentage uncertainty, but you have to calculate and see, right? So the second answer, the percentage uncertainty of the volume of sulfuric acid is 0.08. Um, so let's do the calculation and see whether it is correct. Volume is the pipette 25 and it is 0.04, right? So 25 times 400, right? Sulfuric acid. Percentage uncertainty of the volume of sulfuric acid is 0.08. So it is Volume measured is what? 10. 10 micro. 10. Then it is 0.04 over 10. So it is 0. No, it is 0.4, right? For sulfuric acid. So B is wrong. See, not 0.04. Total percentage uncertainty 0.08. Total percentage uncertainty means uncertainties of both. So therefore it is 0.44. Repeat. Other one is 0.05 over 25. Right? So what is the volume? 0.05. Volume measured is 25. So it is again 5 times 1, 5 times 4. So for acid, okay, yeah. So total percentage uncertainty is 0.08. Yeah. So they are asking about the total percentage uncertainty. Yes. This one is correct, right? Uh, yeah, because when you add the uncertainties, it is 0.08. Percentage uncertainty of the total volume of potassium hydroxide is zero point 0.2. We must have the volumes here. That is wrong. D is wrong. Why? Okay. Now here when we are using the burette, uh, you are measuring the values two times, right? So in when we are using the pipette, you are only measuring it once, right? So 0.05 multiplied by 2 over 25. Yeah, therefore it is 0.04 for burette also, right? For pipette, percentage uncertainty is what? Measured only once, right? Why? Because you are making only measurement only at one place. So therefore, 0.04 over 10. So it is 0.04. For burette, 0.05, two times measured. You are making the measurement two times. So 0.05 multiplied by 2 over measured volume is 25. So when you multiply it by 100, it is again 0.04. So when you add them together, it is becoming 0.08. So therefore, C is correct, right? The reason is in the pipette you are measuring only at one place, in burette you are measuring in two places, right? Okay. Mm, all right. Uh, the percentage unset volume sulfuric acid is 0.08. No, it is 0.05. No, why both are same 0.04. Percentage uncertainty of the volume of potassium hydroxide solution is 0.02. No, it is 0.04, right? It's a very good question, right? Why? When you are using a burette, we are making the measurement in two places. So it means you are making two errors, same error two times. So therefore, absolute error is twice the minimum measurement, right? 0.05 into 2. Absolute measurement multiplied by 2. This so you are making absolute errors two times. So absolute error over measured volume multiplied by 100 is the percentage error, right? So therefore, that is why you are getting both here, but when you are using a pipette, you are making the measurement only once, right? So therefore, there's you get the absolute error of 0.041 only, 0.04 over 10. So that is why it becomes 0.04, right? So therefore, when you add 0.04 with 0.04, the total error becomes 0.08, right? So that is why C is correct, B is wrong. It should be 0.08, 04. This one is just wrong because both the percentage uncertainties are same. This one is also wrong. Is it clear, Buddha? Got it? Right. So be careful, right? So it's a very good one, right? Because most of the time people are forgetting in the burette, absolute error must be measured twice, right? So otherwise, all four answers are seems like wrong, and that's why even I was wondering here and there, it cannot be, right? And then I realized, oh my god, when you are using the burette, you are making the absolute error twice, right? Keep that in mind. Okay. And also, I tell you something else. When you are using an analog, right? When you are using an analog, absolute error is always half the value of the minimum measurement. For example, if you are using an analog scale, you know the analog thing, this indicator is moving here and there. So therefore, always you can stop the rating right at the middle, just like a burette. The burette also, between these two units, you have 0.01, 0.01, 0.1, but you can stop it at half value. one drop, 0.05. That is why the minimum measurement is 0.05. You can end it at half, right? But when you are measuring the weight, you have to measure the weight twice. So therefore, absolute error is done two times. So if the minimum measurement is x, x divided by 2 is the absolute error when you are making one measurement. But if you are measuring the weight difference, always you are measuring the weight difference. So it means you are doing the absolute error twice. So again it is x. So at the absolute error is equal to the minimum reading of the weighing scale, right? So if you are using a digital one, the minimum measurement is exactly the minimum measurement because you can't get a half value. If the digital one says zero point 0.1 grams, you can only up to measure up to zero point 0.1 grams. You can't do it up to 0.05 grams. But if you are using the analog one, you can measure the half point because indicator is continuous. So therefore, your absolute error must be minimum measurement must be half the value between these two uh, gauges, right? Gauge points, mark points, right? Indicator points. So difference in these indicator points divided by 2 is for analogs. For digital ones, the given minimum value can be taken straight away. But again, when you are measuring weight, you are measuring the weight difference. So therefore, you have to multiply the minimum measurement by 2 to find the absolute error, just like in burette. But in pipettes, we are not using graduated pipettes. It is like fixed volume pipettes are used. So therefore, you are just taking and releasing all the content, total content of the pipette. So therefore, absolute error is only 0 point, or anyway the absolute error is only made once. Is it clear? Again, I'm telling you. Uh, right. So those are some things that students are getting things wrong. Right. 12th one. The boiling temperatures of the halogens increase down the group 7 because of the descending the group uh, halogens. Halogens means chlorine, bromine, iodine. Likewise, fluorine, chlorine, bromine. These are like gases. So between them, they have only what? Uh, they are talking about intermolecular interactions. So molecules are becoming larger and larger and larger going down the group. So therefore, ID forces are getting intermolecular interactions are getting stronger and stronger, right? So bond polarities. Bond polarities are not related because we are talking about ID forces. Because these polarities are not permanent polarities. Covalent bond strength decreases, increases. Actually, covalent bond strength are decreasing. When the molecules is getting larger and larger, uh, it is easier to break these, right? So therefore, it's the other way around, wrong. But anyway, whether it is the bond covalent bond strength are increasing, still it is wrong because it doesn't tell you anything about the bond ID forces polarities, right? Dishonesty tells you about permanent dipoles, but there are no permanent dipoles in halogens, only ID forces. Right? Electronegativity is increases. No, it is actually decreasing down the group, but still it is not related. Number of electrons in the molecule increases. Yes, when the number of molecules are increasing, electron cloud is getting larger and larger. So therefore, ID forces are getting stronger. So D is the answer. Number of electrons in the molecules increase. D the answer. Bromine and chlorine each have two stable isotopes. Which statement is true? The atomic radius of Br is greater than the Br 79. No, atomic radius has nothing to do with the uh, uh, isotope. In isotopes, same number of electrons are there, so therefore radiuses are almost the same. There can be some differences, but not much. Electronegativities are also the same. Electronegativities means attraction towards the nucleus by the outer shell electrons. Number of protons are the same, so you can't directly say anything about it. First ionization energies of chlorine is greater than the bromine. Yeah, first ionization is greater in chlorine because chlorine is in the greater period. There and the bromine is at a lower period. Therefore, more shielding is there in bromine. Therefore, ionization is easier in bromine. Therefore, less energy is needed. The mass spectrum of has two molecular ion peaks. Yeah, molecular ion peaks is the greatest. Uh, the peak with the highest molar mass. Uh, Two molecular ion peaks. Right, mass spectrum. So here you have Br and Cl. How many combinations are there? You have combinations of 7935, 7937. Oh, 81, 35, 81, 37. But remember, mass spectrum is only related to m divided by z, mass divided by charge. So if you take 79, 35, you are giving the mass of 9 plus 5, 14, 7 plus 3, 114. For between this one and this. Between this one and this, you are getting another 160, right? Between 81 and 35 again, 116, right? Between 81 and chlorine again, uh, yeah, 7 plus 1, 8. Yeah, here Br and 81 and 37, you are getting 1 plus 7, 8, 11, 118, right? Yeah, here 79 and yeah, so in that cases, you are getting how many peaks? 1, 2, and 3. Three different masses. Three mass spectrums are there. Three peaks are there. So therefore, not 2, you are getting 3. That is wrong. Which statement is true? But even though it is not related to isotopes, statement is true. Other statements are wrong. No? This is wrong. Electronegativity